Hey, good morning, happy evening, good afternoon, good whatever. I hope you're doing fine and having a great day so far. And it's now time to do some pre-calculus. Going to go over some of the homework problems and you did over the weekend or Friday, and I hope that this will be beneficial. I'm also going to show you guys another video with some lady from MIT explaining logarithms that should do a great job helping you understand it better. First, let's go over the order of transformations, which apply to not just logs, but any single function ever created known to man. Um, and that is, you want to follow this order. Start with the innermost part of the function inside of the parentheses, usually. You want to do horizontal translations, left or right shifts, okay, first. Um, Followed by reflections over the y-axis, or horizontal stretches and compressions, depending on, it doesn't matter actually. You could do either or, because -2, you could do the 2 part first or the -1 part, and multiplication is commutative, so it doesn't matter. All right, so remember you're working horizontally first, so the inner part of the function. And then you go to the outer part of the function, like this 4 here. So you're going to do a vertical stretch or compression. The 4 is a stretch this time. And if there was a negative outside, you would do a reflection over the x-axis. And finally, you move on to the -1, which is a vertical shift down. Okay, so to recap this particular example here, we would start with the 2, because this is a +2. You would go to the right 2. Actually, that's incorrect. We would go +2, goes left 2 first. Okay, then we're going to reflect it over the x-axis. So that left 2 actually does become a right 2, but that's after you do the reflection over the x-axis. Scratch that. That's also incorrect. We're not going to be doing a reflection downward yet. We're still on number 2 here. We're going to be reflecting over the y-axis, okay? So remember, everything horizontal happens first. Going left is horizontal, and reflecting over the y-axis is horizontal, all right? So horizontal stuff first. Then we're going to do the vertical stretch by 4, and then followed by down by 1. Okay, on to the homework problem that looks kind of like this. All right, so we're going to graph this, hit the tool, pick the, it's a log, so we're going to use the logarithm graph function there. So we got the graph on here. Remember, there is no, it's actually not touching 0 here. It's not touching x equals 0. It's a vertical asymptote at x equals 0. So it's not actually getting to that line, okay? All right, so let's go through what this one actually does. So we're going to see the 6 there. That's +6. Remember, horizontal shifting is backwards, so instead of going right 6, the +6 actually makes it go horizontal shift of left 6. All right, and then the -x, another horizontal movement, is a reflection over the y-axis. Boom, so it flips it there. And then the 4 on the outside, so that's a multiplication, so that's a vertical stretch. Then the -5, that's going to be a vertical shift down 5. All right, let's save this and check it. Excellent. On to the next question. Okay, this one's a lot easier to graph, but you got a bunch of questions dealing with it. All right, so log tool again. Click that. Boom. Okay, +3 on the inside. Does that go right 3, left 3? Well, the +3, remember, it's backwards, so that's going to be going right 3. So that's exactly what it would look like. All right, let's go through the questions. The domain, okay, the domain is the set of all possible x values. All right, so the domain here, it gets really, really close to -3, but never actually touches it, so you can't use brackets there. You have to use parentheses. So -3, and it keeps on going to infinity. So that's the domain. All right, next question. What is the range? So look at the y values. It starts way down. It starts at -infinity, way down low. Okay, then it keeps on going up, 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 and it doesn't stop. It's infinite. Okay, it goes onward. Now it looks like it kind of plateaus here at 1, but that's deceptive. The graph is still increasing, but it's increasing super slow. Okay, so it's going up super slow. All right. Is this a continuous function? So you might say it's not continuous because it doesn't have any numbers over here, but on its domain, it is continuous. There's no holes in this function, okay? So yes, it is a continuous function. All right, next, is it increasing or decreasing? It's going up, it's increasing. All right, is it bounded? It goes down to infinity, goes up to infinity, so that means it's not bounded. And is there extrema? There's no like roller coaster peaks or valleys, so no local extrema. Is it symmetric? Nope, doesn't look like it's symmetric. Can't really draw a line through the origin either, so no symmetry. And that is it. Up. Is there asymptotes? Yes, there's an asymptote. It's at x equals, what is it? I know you can figure it out. Okay, -3. X equals -3. You got it. Describe the end behavior. As x goes to infinity, so as x gets really, really big, whoop, the problem disappears. No, as x gets really, really big, y goes to infinity. Excellent. All right. Compute. Oh, that's the next question. All right, let me talk about this question here because you guys had some issues with this one. All right, so they gave you this function here to compute sound intensity, beta. You're finding beta, which is the number of decibels. So this function here actually determines the number of decibels. All right, so you're inputting I. Okay, I is the sound intensity. And then they have initial. Okay, I'm not sure of the science behind this, but I could tell you how this formula works. Okay, okay, so they give you intensity here. The soft whisper is 10 to the negative 11. So we're going to do just part A here. You're going to put in 10 to the negative 11 for the I. Okay, I sub 0 is the initial intensity, which is 10 to the negative 12. Okay, so we're comparing these two. Okay, and in order to compare them, you just divide. Okay, you're dividing 10 to the negative 11th divided by 10 to the negative 12th. Remember, when you're dividing powers, you're subtracting the exponents, so it's negative 11 minus negative 12. So that would be negative 11 plus 12. Okay, so if you're adding 12 to negative 11, that just becomes 10 to the first power. Okay, so then you got to do log of 10 to the first power. Okay, so you're thinking, remember log, what's the base of log? If it doesn't have a base, the base is, 10. Okay, so you're thinking in your head this. Okay, logs determine the exponent. So 10 to what power is 10? Okay, so 10 to what power is 10? So log of 10 is actually log base 10 of 10. So this is equal to 10 to what power is 10? 10 to the first power is 10. So this is just 10 times 1. And so your answer is 10. Okay, so the number of decibels of a soft whisper would be 10 decibels. Okay. So hopefully that helps you with this one. For the other ones, you're just plugging stuff in and then you're figuring out the log and just like that. And then you're multiplying it by 10. All right. Hope you enjoy the other video and praying for you guys. Hope you have a great Easter and we'll talk to you soon. Bye-bye.